Welcome everyone to the quick solution of All India Aakash Test Series Medical 2019. Test number 6, code E and F, dated 24 February 2019, and I am here to discuss the physics portion. So let us get started. Let us proceed to the question number 1. An element of length delta L vector is equal to delta Z, K cap is placed at origin and carries a current I equals 15 ampere. The magnetic field on the y-axis at a distance of 0.75 is given that delta Z is 0.75 centimeter. So now let's get started. According to Biot-Savart law, the magnetic field due to small current carrying element IDL at any point P making an angle theta will be given by Biot and Savart law, and that is dB equals mu naught IDL sine theta divided by 4 pi r square. Here in our question, current is given, delta L, that is dl, is given. So putting the values, we get the small magnetic field due to small current carrying element. dB will be mu naught 4 pi into 10 to the power minus 7 multiplied by current 15 ampere multiplied by delta L, that is delta Z, that is 0.75 into 10 to the power minus of 2 sine theta. Here, if you draw a rough diagram in order to discuss the situation, the element is toward z-axis. You can get it from this vector delta L equals zk cap, delta zk cap, and you have to calculate the magnetic field at or on y-axis at any point P, which is located at a distance 0.75 meter. So divided by now 4 pi into r square. Here r is 0.75, so 0.75 square. After solving, we get the value of magnetic field due to small current carrying element as 2 into 10 to the power minus 8 Tesla. But after looking the option, we have to calculate the direction of magnetic field also. Now we know that the direction of magnetic field will be along dl cross r. If you write the Biot-Savart law in vector form, that will be something like this: dB equals vector dB equals mu naught IDL cross r divided by 4 pi r cube. So the direction of magnetic field will be along IDL cross r. So dl vector is k cap, r vector is j cap. So we know that k cross j will be given by minus of I cap. So that is why the net magnetic field dB in vector form can be written 2 into 10 to the power minus 8 Tesla minus I cap, that is towards negative x-axis. So after looking the answer, we will go with option number 1. Let us proceed to the next question, question number 2. Which one of the following statement is incorrect? We have to pick up the incorrect option, not correct option. A magnet does not exert a force on stationary electrical charge body. Absolutely correct, because we know that the magnetic force on any charge is given by Q V cross B, where Q is the value of charge, V is velocity vector, and B is magnetic field. So if velocity is 0, so force will be 0. Absolutely correct, but we have to pick incorrect option. Second, magnetic field lines are closed, continuous curve and extend from south pole to north pole within the magnet. So true, because for a bar magnet, the direction of magnetic field lines outside is from north to south, and as it forms close continuous curve, so that is why within the magnet it will be from south to north. So option number 2 is also correct. Tangent to the magnetic field line at any point gives the direction of magnetic field at that point. Absolutely correct. But we have to pick the incorrect option. Magnetic field lines are widely separated where the magnetic field is strong. Now, that doesn't seem correct because the density of field lines tells about the strength of field. If more density, then strength will be high. If less density, then the strength of magnetic field will be weak. Now, option number 4, we can say that is incorrect. So, we will go with option number 4. Now, let us proceed to the next question. That is question number 3. The direction of magnetic force on a positive charge Q moving with velocity v in a uniform magnetic field B for the following cases. You are having two cases in which in first case magnetic field is out of the plane of paper and velocity is in east direction. In second case, magnetic field is in south direction and velocity vector in southwest direction. Let us understand these cases one by one. First of all, the magnetic force direction may be given by Q vector V cross vector B, where V is the velocity vector and B is magnetic field. So the direction of V cross B will be the direction of force. So case number 1, first of all, in paper we proceed the directions as east, west, south and north. So case number 1, the magnetic field is outward the plane of paper, means from your notebook towards you, perpendicularly outward, and the velocity vector is in east direction. The charge is moving along east direction. So doing V cross B, we will get the direction of force in downward direction, that is south. So force will be in south direction for case number 1. Now let us discuss case number 2. In case number 2, the magnetic field is directed southward. So here is the magnetic field. And velocity vector is in southwest direction, means in the middle of south and west both. So this is velocity vector. Now doing V cross B gets you the direction of force. So if you do cross product of V cross B, we will get the force direction, that is perpendicularly outward to the plane of paper. So force is outward for second case. Now if you go for the option, we will find that option number 3 is absolutely matching. The force is southward for the case 1, that is correct. The force is directed out of the plane of paper for case 2, correct. So option number 3 will be correct. Now let us proceed to the next question, that is question number 4. A helium-2 plus at rest experiences an electromagnetic force. Then, given that E is electric field, B is magnetic field, there are 4 options and we have to pick the correct one. The question is talking about the presence of electric and magnetic field. We know that electric force F electric is given by charge into electric field. On the other hand, the magnetic force is given by charge V cross B, where V is the velocity vector and B is magnetic field. Since the particle is charged and force is acting on the particle, so we can say that E must be there. On the other hand, since the charge is at rest initially, and that's why we can say that force Fm will be 0, magnetic force will be 0 because the particle was at rest, and therefore B may be 0. So the situation arises here, or conclusion we can draw from here is E must be there or E must be present, B may or may not be present. So E must be present and B, magnetic field, may or may not be present. So that's why may be present. So looking at these conclusions, we can say that option number 4 is absolutely correct. Now let us proceed to the next question, that is question number 5. A negatively charged particle enters in a semi-infinite region of magnetic field B directed out of the plane of paper, as shown in figure. Through what angle it is deviated when it leaves the magnetic field? Now, the magnetic field in a region is given this way, perpendicularly out of the plane of paper. A negative charge particle enters the region making an angle 45 degree, and we know very well that it will form a circular trajectory due to the magnetic force and comes out of the region making the same angle, same way, that is 45 degree. After extending these lines, this direction of velocities, we get this as 45 degree, vertically opposite, this as also 45 degree, and hence this angle will be 90 degree. So we can say that this is the angle of deviation delta, which is also 90 degree. So the charged particle will deviate by an angle of 90 degree. So we'll proceed with option number 4, which will be the correct option. Now let us move on to the next question,